The second part of Unit 4 has us use our knowledge of parallel lines and triangles to write proofs. So, using your parallel lines cheat sheet, complete the following proofs. So these are very simple 2-line proofs that are just asking you to practice stating what you know about parallel lines in a proof format, right? So if I was to go through and highlight these 2 lines because I know that they are parallel, based off of this, A is parallel to B. This is my given statement. From this, if I look at the 2 angles that I have marked, I know that these 2 must be congruent because they are the same color. You then have to give a reason based off the relationship. Here, we know that corresponding angles are congruent. So you have to name the relationships and state that they would be congruent given parallel lines. So you're just going to go through and do the same thing for the rest of these. Again, you're going to have to name the relationships and whether or not the angles are congruent. So again, same color, so angle 1 is congruent to angle 2. In this case, they are alternate interior angles. So alternate interior angles are congruent. And again, we continue. So again, we have same color, so they are congruent. This time they're on opposite sides there, so they are alternate, but they are on the exterior, so they are alternate exterior angles are congruent. Now when we look at this one, we will see that we have something different. They are different colors, so we know that angle 1 plus angle 2 is equal to 180 degrees because they're supplementary, and this relationship is same side interior angles are supplementary. Now last one on this page, again, go through, highlight. The highlighting makes this foolproof because very clearly I can see they're different colors, so I know that angle 1 plus angle 2 must equal 180 degrees. Now, these are same side, but they are exterior, and again, they are supplementary. So when you're given parallel lines, you'll be able to say something about the angles given one of these relationships, right? So depending on the angles that you're looking at, you might have alternate interior, you might have corresponding, depends on the proof. So an example of this is on the next page. Given QD is parallel to UA and QU is parallel to DA, we want to prove that DA is congruent to UQ. Now this is a line, not an entire triangle. So when you see that there's a piece, you know you're going to have to use CPCTC. And before that, you have to prove the triangle is congruent, right? So I'm going to have to prove my triangles are congruent in some way. So if I look here, if I want to highlight my 2 triangles like we were doing back in Unit 2, I highlight triangle 1 and triangle 2. I can see that the colors are overlapping. So I have a side here. And now if we look at parallel lines, right? Let's look at QU and DA first, right? So this is our transversal. If I was going to highlight this, So I can see that this green angle is present in both of my triangles. And if I look, they're on opposite sides and they're on the inside of my two parallel lines. So here I have a pair of alternate interior angles. So this will give me an angle. Now, that was my first set of parallel lines. I'm going to look at my other set of parallel lines. So again, I have my parallel lines. And now again, if I highlight, let's use some brighter colors. Let's do some obnoxious green. Actually, no, I already did green. Let's do purple, right? So here, we're saying that these two are the same and these two are the same, but that doesn't really help me. I have to then look and say that so here it's kind of muddled, but if you look, these two are both highlighted as that red color. Again, these are alternate interior angles that I know are congruent because they're on opposite sides of the transversal. So if I look here, I have an angle, a side, and an angle, and the side is in between my angles, so I can prove that these are congruent using angle, side, angle. So to write the actual proof, I was kind and gave you guys the reasons so we can just focus on understanding what's going on. Right, so you start with the given and your last line is your proof statement. This is what you are working towards. DA is congruent to UQ. Now, the line before CPCTC has to state that the triangles are congruent. So if we name the triangles, we know that AQD must be congruent to AQU. Now there's only two things you have to fill in, right? So reflexive postulate, that's the side that is highlighted twice. So QA is congruent to QA. Now I'm going to state two angle congruences here because it's the same relationship, so you don't really need to go through and label it twice. Now if I go through and label these 1, 2, 3, and 4, I'm able to say that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4 because alternate interior angles are congruent. Because I have parallel lines, I know alternate interior angles are congruent. And that's pretty much it. Now if we look at the next one, I'm given one set of parallel lines. KA is parallel to HY and T is the midpoint of KY. So if T is the midpoint, then I know that KT and TY are the same. Now you should also see that there is a specific shape to this proof, right? So first, if I highlight, there's nothing that I highlight twice, but I do have that bow tie shape. So these two angles, angles 1 and angle 2, should be vertical angles, which we know are congruent. Now I want to use my parallel line, so if I extend out, and if I go through and highlight, I can see that I have matching angles here. So angles 3 and 4, and these are alternate interior angles. So again, I have an angle, a side, and an angle, and the angles are on both sides of the side, so we're going to use angle, side, angle. So let's write the proof. Write your given statement. KA is parallel to HY. T is midpoint of KT. I can write my proof statement because I know before CPCTC I have to prove the triangles are congruent. So I can even say KAT is congruent to YHT. Vertical angles are congruent, so angle 1 is congruent to angle 2. Yes, we are combining these into one line now. Definition of a midpoint, that gave me that KT is congruent to YT. And then finally, angle 3 is congruent to angle 4 because these are alternate interior angles of a given set of parallel lines. Okay, page 4. MT and HA intersect at B. MA is parallel to HT. MT bisects HA. So we've got a lot of information here. But right away, you should look and see what type of shape I am given in this proof. This is our bow tie shape. So when there is a bow tie, you know that you have a pair of vertical angles. So you already have one pair of angles that are congruent. We know that these are parallel lines. So we should get used to this by now. I have a pair of alternate interior angles, angles 3 and 4, because we want them to be inside the triangles and they end up being on opposite sides. And then finally we have the MT bisects HA. So MT is striking this line at the middle. So I know that HA is being split into 2 equal pieces because MT is bisecting this length. So if we look, I'll end up with angle, side, angle again. So first we write out our given. Now, when you're actually writing a proof from scratch, your statements can be in slightly different orders. It doesn't matter, but in this case, we're going to look at the reason. So vertical angles are congruent. I named them 1 and 2. So angle 1 is congruent to angle 2. Definition of a segment bisector. So we'll name the sides that are going to be congruent as a result. So HB is congruent to AB. Alternate interior angles, so we name those angles 3 and 4. Now I can say that the triangles are congruent, so MBA is congruent to TBA, and because of that, I can say that 2 corresponding sides are congruent through CPCTC. Used in the diagram below, 4 pairs of triangles are shown. Congruent corresponding parts are labeled. Using only information given, which pair of triangles cannot be proven congruent. So our valid methods for congruence are side, angle, side, 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 angle, angle, side, and angle, side, angle. You should not be writing down any bad words on your paper. So we have to look and see what's labeled. So here we have an angle, a side, and a side. Here we have an angle, and a side. Here, angle, side, angle. And this one is a special case that I forgot to write down, HL, because this is a right triangle. So we have our hypotenuse and our length, our leg. So the only one that is not valid is A, because the angle, if you have 2 sides that are congruent with an angle, the angle has to be in between them, right? So it would have to be a triangle that is marked you would have to have two sides with the angle between. Anything else when you just have two sides would not prove that they are congruent.